Jim's radio shop. We're going to be looking at this preamplifier made by Soundtech, Preamp 1. Now, this is a small manufacturer. I'm not sure how much stuff they made, and probably made locally near Toronto here, I'm going to guess. And it's come to me, the owner has pointed out a burned up resistor inside. We don't have too much information about it. There's a pretty sure that's a blown fuse in the bag here. Let's see. It's a 1 amp fuse. Blown. But we do have this manual. Extraordinary design in tube technology at affordable price. Agincourt, Ontario, 1991. So this was made in, at least this manual was made in 1991. Nice write-up. Warning about high voltage because of these vacuum tubes right here. Yes, this guy has 2 vacuum tubes in him. Even in 91, people were going a little nutsy for vacuum tubes. And don't get me wrong, I'm not knocking vacuum tubes. They're a perfectly good technology with many advantages over transistors. But they have some shortcomings over transistors. Yeah, just your basic manual here. It's not going to help us too much. Nicely done manual though. So we'll just set that over here. And, okay, we'll take a good look at this guy here. He's got a couple chips. Boy, he's got quite a range of technology. It's got some chips in it, so it has a couple integrated circuits. Lots of large capacitors here. You see the burned up resistor. Something very curious about how that's been done. It looks well built, well designed. Lots of space. Nothing too crowded. It would appear to have been. Yeah, it looks well built. Yeah, I'm looking at things like the use of shrink tubing, the way components are laid out on the board. Soldering that I can see. I can't see too much because I'm looking at the top of the board, but I see some. And I'll give you a close-up look at the burned up component here. It's right here. Turn my camera here into a microscope. It even helps me see it better. You know, the component right beside it, you see 3 of them there. The two of them you can read TRW quite clearly, but the last one, it's not looking terribly healthy either. So, I can see the traces. You can see the traces under the board. You can see them right through. And you can pretty much make out the connections. And I see that the burned out resistor is connected to that guy right there. I get a little more light on him. He's quite the suspect, that guy. So we're going to start by testing him. Okay, so we can test that fairly easily just by looking for short circuits through it. Put my meter here. So you can see it just like me. First of all, let's see what happened to these resistors. So it looks like they're reading about 500K through there. Yeah, one of our challenges is since we have no schematic, and those resistors are burned beyond recognition, so they appear. It's going to be tricky to determine their correct value. Now, put my meter back on. Diode test. Well, those readings look pretty good. And, you know, testing things like that in circuit without the circuit diagram is well, it's not the smartest move. Test the power supply diodes. Well, all the power supply diodes look good. A couple of little signal diodes here. More smaller diodes. And they also test good. Okay, so we haven't concluded about this particular guy. Let's see. Just follow the trace around. Here's another diode, a couple diodes down here. Uh-oh. Well, there's one that's blown. Two. The two diodes blown here. Well, there's the short circuit. Two diodes blown in there. And what is going on here? The two diodes are in series, but one's turned one way, one's turned the other, so one may be a Zener diode or something like that. Looks like one end. Looks like a regular diode. Well, those guys are going to have to come out. And what would cause those guys to blow? A defect in this, it's involved. And it also goes over to this capacitor here. And you know, that's the strangest thing. This capacitor appears to go through the board in a place where there's no trace. And I see there's lots of trace holes, points for components with nothing installed. So this is must be a multi-purpose board in here. So the trace, which appears to head to this capacitor, doesn't. I'll show you that. Oh, you can see it like that. So here's the blown diodes. You can see the trace running along and coming up to here. And you can see the holes for the component leads to go through. But this lead, no trace underneath. So chances are the wire just swings over and is soldered here. And in fact, these capacitors look a little jammed in there, don't they? And this one seems to be a little, by the angle of this wire, as if they're a little big. Now my guess is these have been changed out, and these are larger capacitors. There's another one down here. And I'm going to guess that this was the original, and these are replacements. It's only a guess. There's a 400 volt 10 microfarad. These are 20 microfarad, 450 volt, 2450, 2450. 450. Couple of nice transformers there. Could easily be 450. Well, it wouldn't be 450, it'd be maybe 300 volts B plus in this. And a little bit of circuitry on the back port too. And there's a relay right there. So this is probably the it's right on the outputs, I believe. Let's take a look. Output. record, tape, CD auxiliary, and phono. Nicely done. Oh, there's a nameplate. Made in Canada, Agincourt. Preamp 1 serial number. 11510075. Take a guess, this is number 75 that they built. If we want to lift this board up, that's not an easy matter. All kinds of wire leads all the way around the board. Very hard to lift this board. Let's give a little test on this the capacitor here. Not very valid doing this, I don't think. It's big electrolytics. Wow, it's charging very, very slowly. I'm not sure if I can increase that. Oh, these guys aren't parallel, I think. Another set of diodes there. Probably the low voltage. Yeah. Well, it's not a dead short. You kind of wouldn't expect that. There's another relay here. You guys got two relays on. This one appears to be blocking the input. This one, you could guess, blocks the output. Or simply a time delay. You know, this could just be a time delay. Well, we can start it up on current limiting, which I think we should. And watch what smokes. Let's see what happens if we start her up on it with current limiting. Okay. On this we want fairly high limit, which I have on. Yeah, switch. Okay. Everybody ready for this? So what you want to watch is the light bulb here and here, this back light bulb. It should come on very briefly and then dull right down and maybe even disappear from view. If it comes on and stays on, we know we're in trouble. But better the light comes on than something in here fries. That's what we're trying to prevent. And it won't necessarily prevent further frying. But if I'm quick, you should be okay. I think what I want to try to do is identify some of the high voltage circuitry right away for my own safety. And you can certainly see this is a bridge, so is this one.
nothing about those two transformers. There's no writing on them or anything. Yikes. So I have no way of telling which is which. I think it would be this is probably the high voltage side over here. Got these high voltage capacitors. See, this capacitor here, which maybe you can't see it, is only 25 volts. It's a big guy, 4700 microfarad. So this is clearly the high voltage, this part anyway. Now why are there so many capacitors here? I've got more big ones over here and here and here, all over the place. Don't know. Let's give it a go. Okay, we're armed. Push this switch down. The power is now supplied to the plug, but the switch is not on the unit. The unit has a light right down here, which you probably won't see. From your camera angle, and we're at 115 volts today because it's another hot day and everybody's air conditioner is running, including mine. So here we go. Okay. Switch is on and nothing happened. No, that's because the fuse is out. That's why they call me a technician, because I know things like this. So we'll put in another fuse. I have to put a 1 amp fuse in. And a 1 amp fuse. Too blind to read these without my magnifier. 100. And it's scratched up pretty bad, but I think that says 2 amps. That's a 1.5 amp. I really want a 1 amp. That's a 9 amp. I should just look at the element in it. You could probably go with a 1.5 amp. 1.2 amps, that's even better. Half amp. Half amp. Let's try the 1.2 amp fuse. This is the blowing one. Oh yeah. Let's see if you can get a look at it. A little more light on the subject.
Now you can see it's a wire wound fuse. And it's simply blowing some of the wire out right in the middle there. Looks like a pretty dramatic failure to me. What happened to my 1.2 fuse? What happened to it? Where'd it go? Did you see what I did to it? I thought I put it right here. Oh, for crying out loud. Oh, maybe that's it there. $1.2. Okay. Power's off to the unit. Okay, this time I may very well just pop the fuse. I may also get some smoke out of these parts again, because the fuse may hold in, the current limit may be enough, keep the fuse going, keep everything going, and smoke some of these parts. Remember, I'm finding a short on these. Exactly why that would happen. Not clear to me because I don't have a circuit diagram to really study these. Well, let's do one more thing just before we fire this guy up. 33 ohms. No. Not 33. About 27K. 27K. That might be the bad actor right there. What's he doing down there? At 265 ohms. It's discolored. When I look at the circuit, I can see that this guy here, he's probably just another one of these. And they seem to run, let's see, this one through this wire. These are just in series. For some reason he's got a series of resistors. They don't seem to be tapped off anywhere. So my guess is this is somebody's replacement of this guy. And he's gone and tried to make it up to... That's really burned up. You can put three resistors in here in hopes of getting the same resistance. Somehow he worked underneath, which means he must have lifted this board, and that would have meant resoldering all these connections. Yikes. At least I think you'd have to do this one, these ones, maybe these ones, and you can probably tip the board up at that point. Well, that's the deduction or the story I'm getting out of this. These diodes shorted.
these resistors ruined. Now if you've got 4 resistors of the same value in series, you burn one up, you burn them all up. These two guys seem just like new, and this guy seems more cooked. Well, there is a difference. They aren't just in series. At this point, there's a trace that goes from here. Oh, you're having a hard time seeing this because of this light. Shame on my cameraman skills. It's a little better. So, I'm very suspicious of this guy. And it could be due to capacitor failure. And it's suspicious that all 3 of these look different than this one. You know what I said earlier about these ones looking like they're crammed in? These ones are smaller than this one. Look, there's another one over here. You know, these match. If these are original and they're 10s, and there were a bunch of them and they were replaced, they should have been replaced with 10s. But these are all 20s. All of them. And whoever built this installed the components so the values were turned upwards to be seen, which is a sign of a experienced designer and builder. So these are all turned upwards. So it suggests they are original. Although it's very curious about this weird connection over here. Okay, shall we try turning it on again? So if it holds in, I'm going to want to hunt down the B+ right away and find out what it is before I get electrocuted. Holding it in with defective parts, even with a low voltage supply, like supplying it with 90 volts instead of 120. No guarantee I won't do more damage to currently undamaged components that were protected by the fuse. And I may very well just pop the fuse. So let's give it a try, because I think we need to poke around a little bit. So here we go. Exciting moment. Okay. We're armed. And switches off on the unit. Okay, we're armed and we're dangerous now. We're at 116 volts supply. And we can make an assumption on the high voltage. Let's do that. We'll hook up my meter in advance here. Good too, so I'm not jumping around like a crazy guy trying to take tests on a unit that's got smoke coming out of it by poking around with prods. That's not going to go well. Okay, so this meter is now connected to these capacitors. I think we're going to put it on the 1000 volt scale, because maybe there's a little more than 200 volts there. If you listen carefully, you'll hear the fuse blow. Everybody ready? 3, 2, 1. Well, I don't know what to make of that. The panel light came on and stayed on. There was an immediate snap. And of course, you can't hear where it came from. It came from over here somewhere. That's not good at all. I think the fuse just held right in. Yep. Fuse held. I noticed my light bulb was on, but I didn't take too much time to look around that way. I also saw the voltage rise on this. Oh, I know what the snap was. The snap was that relay. Yeah. Pretty loud snap. So I think we can try it again. Ready? Okay, I turned it off because I heard something. Now, I didn't hear that snap that time. I think after a couple of seconds I heard this relay operate. Quite a different result. What to make of that? Good question, what to make of that. Let's see if anything got hot. It wasn't on very long. No. I thought I heard something crackling. But you know, I get a little nervous when I'm doing this, as I should. You should always be nervous during this process. Let's give it another go. We're still on current limiting. There we go. There's the relay snapping. So we got almost 300 volts. See, the tubes have lit up. Getting a little bit of heat in there. Just a little bit. Nothing on that. Nothing on those. No aroma of burning parts. Well, that's good. Now we can do a little more testing here. Okay. Bearing in mind now there's 300 volts kicking around this unit. 300 volts are very painful. We don't want to find that out using our human test lead. You know, it's drawing a fairly heavy current. I can tell that because I can still see a bit of light on my light bulb, and the line voltage is about 95 volts reaching this instead of a full voltage. We're on 1,000 volts. Nothing. 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 There's some voltage there. Not much though. 200 volt scale. We got 8 volts across those burned up resistors. 1.3. Look at that. 135. 135 in combination. These two are doing the full B plus voltage there. Ooh, they're hot. They're definitely getting hot. I can see them discoloring right in front of me. They're up around 40, 42, up around 40. So those guys are in the process of burning out, I believe. Yeah, it's a little tough to test this guy here. Yeah. Let's take a look at the voltage on this capacitor here. 8 volts. 8 volts. That's probably a low voltage supply. $279, 100. $126, 279. And 100 on that one. 126 on that one. Tubes are about the same temperature, getting their normal, producing normal amount of heat. Well, I think, clearly the problem lies right in here. Two blown diodes, burned up resistors, discolored resistor, and maybe this guy there too. Capacitors seem okay. Okay, well, I think that's enough of the checkout. I never did hear this relay operate either. And I'm guessing it's not going to operate until those components are corrected. Well, thank you very much for watching the checkout of this preamp. And I'm going to have to lift the board out, remove these components, replace the two diodes, try to sort out what's going on with these resistors, including a guess at their value, since I think they are disturbed. All these electrolytic capacitors appear to be good, and a good deal of this circuit is operating. Of course, it's a two-channel device, two channels, so kind of see the two channels here. That might help me sort out what these guys are. And that's it for now. Thanks a lot for watching.